All right, here we go. Let's take a look at some more antiderivatives, and we're going to use it for integration. So we're going to do some crazy integration coming up later on, but I want to recognize a few more things for antiderivatives. So let's take a look at this. If I was trying to find the antiderivative of this, so we can rewrite these fifth root looking things as one exponent. So we can write them as a rational exponent. So remember, the rule is whatever the root is goes on bottom of the fraction, and whatever the power is on top. So it goes back to rewriting things like we did way back in chapter 3 derivatives. Plus, what do we got over here? This is the same thing. We've got the fourth root of x cubed, so this will be to the 3/4, and because it's on the bottom of the fraction, it's going to be negative. So the first thing we're going to do is rewrite it. Now can we integrate that or find the antiderivative of that? Sure. What is the rule here? We bump it up 1, so we're going to take 2/5, bump it up 1, that means add 5/5 to it, so we end up with 7/5. So it's kind of weird looking. Then what do? Well, technically speaking, we're dividing by 7/5. You can write divide by 7/5, or I just flip it and multiply. We're going to multiply by 5/7. So I think it's much easier to flip the fraction and multiply. So over here, careful with your negative here. If I add 1 to this, I'm adding 4/4 to this, so that'll leave me with 1/4. And then what do? I've got that 4. I'm going to times it by 4 over 1, which is just, what, 16? So really, if I go back to rewrite this thing, I'm looking at 5/7 x to the 5th root of x to the 7th power plus 4 times 4 was that 16, the 4th root of x. Plus, don't forget about c. You never want to forget about c. That's easy points, especially if you're taking the free response on the test. You got to add that plus c, some constant out here. So there's the antiderivative of this crazy function to begin with. So we're kind of up in the ante, if you will, antiderivative. Ooh, that was rough. We're kind of going to take it one step farther here. So we can do some rational exponents. How about these? These are ones I kind of want you to recognize, and they're just basic. Later on, they'll get a little crazy, but can you recognize if this is the derivative, what was the original function? Well, what derivative makes 1 over x? That's right, it's the natural log. Remember that? Plus some constant c. So I want you to realize that because the derivative of natural log of x is 1 over x, I can actually find the antiderivative. How about this? Do you remember, or do you know what the antiderivative of e to the x is? I love e to the x. It's just e to the x all day long. I love it. So because the derivative of e to the x is e to the x, I can find the antiderivative. And notice I'm throwing some different notation out at you. Find the antiderivative of that is going to be, a little trig. The derivative of what is cosine? That's right, it's sine. So again, we're keeping these simple. Later on, they're going to get cray-cray. And how about this same thing, the dy dx? I'm going to say what gives you sine. Be careful here because it's negative cosine. Because remember, cosine, the derivative of cosine is negative sine, so I'm going to go negative that to get to there. So these are some basic ones down here I want you to know. Up top, I want you to be able to rewrite these crazy root problems. And that's really basically the new stuff, except for initial condition. So we're going to figure out, that c is so important, but sometimes we can find that c, and that's what I want to do. Sometimes we get enough information where we can actually find the entire original function. So given this, let's take a look at the first one. If I've got the f prime equals this mess, and I know the f of 2 is 8, I can actually find the original function. So let's take the antiderivative of this. So I'm going to say, bump this up 1. X cubed, divide by 3. Well, 3 divided by 3 is 1. Bump up x1 will be squared. Divide by that will be give me that 1/2. And plus 4x, bump it up 1, plus some constant c. Well, because I know the f of 2 is 8, I can say, sure, this is going to equal 8 when x is 2. So you can replace x with 2, plug in your little 2 there, and replace the f of 2 with 8, and now I can solve this bad boy for c. So this was, careful, my handwriting's terrible. The cubed here. So let's go ahead and clean this up. Let's find this c. I'm going to say 8 equals 2 cubed is 8. 2 times 2 is 4. Half of 4 is 2. Plus that 8, plus that c. What is c going to be here? It looks like 8 minus 2 plus 8 is going to be 14. So c's got to be what? Subtract 14 from both sides. C is negative 6. So once I have all that information, what do I got to do? I can go back up to my original thing and say, hey, I know what c is. C is actually negative 6. So maybe in this case, I'll go ahead and say minus 6. So there is the function. So I'm actually going to find the original function, and what is that value of c? Pretty cool. Let's try the next one. So this one you may want to rewrite it as x to the 1/2 power before we start to get rolling here. So that really is the derivative. Can we find the antiderivative? Sure. So what will this function be? The f of x is going to be bump that up 1. So add 2 over 2 to it, you get 3 over 2. Then I'm going to multiply that. So I'm going to multiply by 2/3. So flip that fraction and divide. Plus I'm going to go 3 to the x plus some number c. So let's clean this up a little bit. I know my function is going to be, those cancel out, I'm left with 2. This is going to be the square root of x cubed plus 3x plus some number c. Let's go ahead and sub it in. I know that when the x is 1, y is 4. So let's go ahead and plug that in. And this is going to be 1 cubed, which is nice. Ooh, I like putting 1 in there. That's pretty nice. So when I get this going on here, the 1 cubed square root of blah, blah, blah is still 1, no matter what you do to it. So this is going to be 2 plus 3 plus c is 4. So what happens here? 4 equals 5 plus c. So it looks like c's got to be -1. So my function, if I go, my function, replace the c, plug it back in here for the c, I'm going to get 2 times the square root of x cubed plus 3x minus 1. So there's my function. We're going to find the actual value of that c, and that's the initial condition. Awesome. Can we step it up one level higher? Let's take it next level stuff. So what if I gave you the second derivative, and I'm going to mix in some of that trig stuff we were talking about. So let's get this rolling. I know the second derivative is this. Can we find the first derivative? Sure. Derivative of what is cosine? Well, that's going to be the sine plus some number c. But it tells me here when y prime, the y prime of pi over 2 is 2. So I can plug that in. So the sine of pi over 2 plus c is got to equal 2. What is the sine of pi over 2? If you think to your unit circle, straight up and down, that's just 1, isn't it? So I get something like this. So c must equal 1. So I know that my derivative, my y prime, is going, I'm going to write it over here, y prime equals the sine of x plus 1. Very nice. Now I'm going to bump him up and say, great, what is my y? So basically I'm giving you the second derivative. I need to get back all the way back to my function. So what gives me the sine? Well, it's that negative cosine x. So it just keeps rotating back and forth. Plus 1x plus some number c. Now let's do a little plug and chug here. Excuse me. And I'm going to plug in, pi over 2 again. So they gave me pi over 2. Now in this case equals 3 pi. So the negative, so in my function, in the original, pi over 2 makes 3 pi. So I've got pi over 2. Plus 1 times pi over 2 plus that c. So what is the negative cosine of pi over 2? Well, cosine of pi over 2 is actually 0, or -0, it's just 0. So I've got this pi over 2 plus c. So what do I do here? Subtract pi over 2 from both sides. And what will that give me? That'll give me, that's 6 pi over 2, 5 pi over 2. If I subtract it from there, I'll get 5 pi over 2. So that lets me know my original function will be negative cosine x plus 1x minus, not minus, plus 5 pi over 2. Sorry. Excellent. So if you take a half a pi away from 3 pi, you get 5 pi over 2. There is my initial function. Holy cow. That's a lot of work, a lot of fun work though. And that's initial condition. This is it. Last problem already. We're going to now take that into word problems and particle motion, maybe some kind of linear motion, some kind of that vertical motion, throwing a ball in the air, whatnot. But let's take a look at a particle motion. So I'm going to give you a bunch of these. I kind of went short video. I want to give you lots of examples for you to practice and work. So I hope you enjoy that. You're welcome. So we got this particle moving along. I give you the acceleration. So I know the acceleration, which is great. So I've got this acceleration. And what do they ask me to find here? They're giving me the velocity is 18 when time is 2. They're also giving me this initial position. So let's go to velocity. So I can go to velocity if I just take the antiderivative. Remember, so I used to give you like the position function, the x of t, and I'd say, hey, find the derivative, which was the velocity. Then I'd say find the derivative of that, which is the acceleration. So we used to kind of go down like this. Now maybe we're going to go up. Maybe we're going to go the opposite way. Now we can do antiderivatives. So if I give acceleration, bump up t to t squared, divide by 2 will give me 6t. Bump up a constant to 4t plus some constant here. Now let's find that. So basically, if the problem's telling me the velocity at 2 is 18. So let's plug that in. The velocity at 2 is 18, so I'm going to replace my t with 2, and I'm going to solve for c here. So let's find out what that number really is here. So this is going to be 18 equals 2 squared is 4 times 6 is 24 minus 8 plus that c. I'm looking at 18, 24 minus 8, 16. So c looks like it is 2. So now I know my velocity function is really what? It is this negative 6t squared minus 4t plus 2. So there is the velocity function. But my goal is, what is the position of the particle at t equals 3? So I need the position function. So let's do it again. We got to find the antiderivative of that. So if I'm going to find the antiderivative, so I'm looking for this. Bump up t squared to t cubed and divide it, we get 2t. Bump up that t to t squared, divide it, you get 2. And we're getting close. This is the general one. Now I want to find the specific case. Oh, wait, it gives me something else here. The initial position is 8. So what does the initial position mean? That really means when time is 0. So if you want to plug in 8 and 0 for all these, that's great. But if it's the initial position, that's a fancy way of telling me, hey, c is really 8. So I'm not going to go through all that. Plugging in 0, you're more than welcome to. But basically, I know because these are all zeros, it's going to give me 8. Now, can I finish the problem? Sure, I'm going to plug in t equals 3. So I want to know what is the position at 3. And then we're just going to clean this up, and we are done and done. I love it. So put the 3's in all of these t's here. I'll get the plus 8. Excellent. And here we go. So what do we got here? 3 times 3 times 3 is 27. Times that by 2, you get 54. 3 squared is 9. Times that by 2, you get 18. 2 times 3 is 6 plus 8. So let's just finish this out. If I take, I would add the 6 and the 54, 60 minus, boom, put that together, 10. I think it's just 50, isn't it? And what are we talking about here? We are talking about, because this was in centimeters per second, this is going to be 50 centimeters. So the time at 3 seconds is 50 centimeters. That is it. So some more antiderivatives, and we're looking at some initial condition problems here, and that is it. Good luck on the practice and on the math check. Peace out.